Hello, this is going to be the last video for the first set of videos on examples of working out some questions involving Laplace transforms. In this example, we're going to rectify a slight conceptual point that we failed to address in the previous example. Even though there was nothing wrong in the previous example, it's just that the answer we gave was slightly incomplete, and namely, it didn't refer at all to the domain. So let's make clear what we mean by this. The example we're going to work on will be a function f given by f of x is equal to t squared. Sorry, it should be x squared equal to x squared minus e to the power minus 9x plus 5. And so the question here is what is Laplace transform of this function? But not only we want to find the expression for the values of this function at each variable s, but we also need to know what are possible values of s. In other words, what is the domain of the Laplace transform? And as we are now used to, we want to get a domain that's consists of all the numbers bigger than a certain number. So we're going to put here s bigger than some c, and we want to know what is c. We're expecting that we can find such a domain, and let's see if we can. The technique for finding Laplace transform itself, irrespective of the domain, is similar to the one in the previous example, where we use linearity to break down this expression into the following. And then the second step here is to make use of the existing formulas, and the formulas that will be useful here will be the one that says that the Laplace transform of x to the power n is equal to n factorial divided by s to the power n plus 1. And at this point, we also need the information for which s values is this formula valid. So maybe I should be a bit more consistent with my own notation and put in the s in the left hand side as well. So the question is, for which s values is this equality true? And the answer to that question, which we would have gotten when we were deriving this formula, if we had derived it, is that this is true for all s values bigger than 0. Great. So we have the domain for the first part. The second part is actually similar to this one. Sorry, not the second part. The third part is similar to this one, where we have L of 1, and where 1 can be represented as x to the power 0. And so the same domain will apply. But for the middle term here, we would want to use a different formula, because there's no way we can match e to the power minus 9x with x to the power n. And the different formula we want to use there is the following, which says that Laplace transform of e to the power some number a times x evaluated at each s is equal to 1 over s minus a, and there the domain is all the s values that are bigger than a, whatever the a value is. Now in our case, we want, as we already said, for the first one, we want two instances of the formula. One when n is equal to 2, because we've got a square there. So in that case, we will get 2 factorial, which is 2 divided by s to the power 2 plus 1, which is 3. And we also want to make use of the formula here, and that will give us 5 times, I'm keeping the 5 I had there, L of 1, which is Laplace transform of x to the power 0. So to get 1, I need to make n equals 0. So that will be 0 factorial, which is 1, divided by s to the power 2. So that's when n is equal to 0. So then 0 plus 1 becomes not 2, but 1. I made a mistake there. In other words, it's just s. And the middle one, the middle term, will be minus 1 over s minus a. And what is a? A is the thing that is in the exponent in front of x. And here in the exponent in front of x, we have minus 9. So a will be minus 9. But there is another minus there. So it altogether becomes plus 9. Now, these are the values. And what about the domains? So the domain for the first and the last one is all the s's bigger than 0. But for the middle one, it's all the s's bigger than a. And a is minus 9, as we already said. Now, in order for the whole expression to be defined, we want each of its parts to be defined. So what we want to do is to take all the common s's to all the terms. So we want to intersect the domains, in other words. And so taking all the s's that are simultaneously bigger than 0 and bigger than minus 9, we will end up with all the s's that are bigger than 0. So then the answer will be that this thing is equal to 2 over s cubed minus 1 over s plus 9 plus 5 over s, with s being bigger than 0. In the case when we would have here not minus 9 but plus 9, let's say we had e to the power not minus 9x but plus 9x, then a would have been 9, and then taking the overlap of these domains would have no longer given us s bigger than 0. We would have then had to take s bigger than 9, because those s's which are simultaneously bigger than 9 and bigger than 0 are those s's which are bigger than 9. Great. This should be, at least there is nothing more planned after this example video. This should be the last example video on this week's work on Laplace transforms. And if you have any questions or you're stuck anywhere, please make use of the forums and the chats to get hold of the lecturers and ask your questions, as well as the tutors. Good luck with your studying and all the best. I wish you are very well in these hard times.